Hello students, in this video from the chapter Current Electricity, we are going to study about Wheatstone Bridge. So Wheatstone Bridge is basically an arrangement of four resistances. Now among these four resistances, in this arrangement we are going to determine one of the resistance quickly and accurately in terms of the remaining three resistances. Means जो एक unknown resistance होगा among these four resistances, we can find out that resistance using Wheatstone bridge. So basically Wheatstone bridge is an arrangement of four resistances that is used to find or determine one unknown resistance quickly and accurately in terms of the remaining three resistances. Right, so what we are going to do in Wheatstone bridge, we are going to find the condition by which we can find that one unknown resistance in terms of the remaining three resistances used in a Wheatstone bridge. So if we talk about its structure, so Wheatstone bridge is basically an arrangement of four resistances in the form of a quadrilateral. Here I am going to draw a Wheatstone bridge. So it is basically in the form of a quadrilateral where each arm contains one resistance. Alright, now this is the quadrilateral A, B, C, D. Here each arm contain resistances P, Q, R and S. Now the point A and C are connected with a cell or a battery having EMF epsilon, like this EMF epsilon, right? So a Wheatstone bridge consists of four resistances P, Q, R, S. Here in the terminal BD there is a galvanometer, or we can say a sensitive galvanometer, right? Between points B and D there exists a sensitive galvanometer. I am going to denote it by capital G. So Wheatstone bridge consists of four resistances P, Q, R and S connected in the form of a quadrilateral A, B, C, D. Now the points A and C are connected with a cell or a battery of EMF epsilon, and between point B and D there is a sensitive galvanometer capital G. Now let capital S be that resistance which has to be measured, because we said that कि हम galvanometer इसका Wheatstone bridge का यूज़ करके एक unknown resistance कैलकुलेट कर सकते हैं. सो हम सपोज कर रहे हैं दैट द unknown resistance जो हमें फाइंड करना है, let it be capital S. Alright, so what we are going to do, we are going to adjust a resistance capital R such that there is no deflection in galvanometer. How it works, काम कैसे करता है Wheatstone bridge? Wheatstone bridge को हमने सेटअप किया, उसके बाद S जो है वो अननोन रेजिस्टेंस है जो हमें कैलकुलेट करना है. P एंड Q विल बी द फिक्स्ड रेजिस्टेंसेस, इनमें हम कोई चेंज नहीं कर सकते. बट R जो होगा, this is free. We are free to adjust the value of capital R, and we will adjust the value of capital R such that the bridge, or we can say this arm containing galvanometer, the sensitive galvanometer, shows no deflection. Means ये जो आपके पॉइंट्स हैं B और D, इनके बीच में हमने जो गैल्वेनोमीटर कनेक्ट करा हुआ है इसमें कोई भी डिफ्लेक्शन ना आए. हमें R का वैल्यू ऐसा सेट करना है. दिस कंडीशन, जब ये कंडीशन सेटअप हो जाएगी, उस कंडीशन में हम बोलते हैं दैट व्हीटस्टोन ब्रिज इज बैलेंस्ड. What do you mean by a balanced Wheatstone bridge? तो balanced Wheatstone bridge का मतलब है there is no deflection in galvanometer, right? In galvanometer means galvanometer में कोई भी deflection नहीं है. That means there is no current flowing through the galvanometer or through the arm BD. Now in this condition the bridge is said to be balanced, and at that situation the potential difference across the galvanometer is also zero. There is no potential difference between point B and point D, or we can say that both are at same potentials. So in this condition, in the balance condition of the bridge, the condition that exists is P upon Q is equal to R upon S. P upon Q is equal to R upon S, or the unknown resistance capital S is equal to Q upon P into R. This condition we can also find using Kirchhoff's law. ये अभी हम निकालेंगे. By using Kirchhoff's law इस balance की condition को हम derive कर सकते हैं. We will do it later. So capital S, the unknown resistance is equal to Q upon P into R. Means आप unknown resistance calculate कर पा रहे हो in terms of the remaining three resistances. Here this Q upon P shows the ratio of resistances Q and P, and the resistance capital R is that resistance that we are going to adjust. So the arm containing resistances P and Q, these arms AB and BC, the arms containing resistances P and Q are called ratio arms because we are using their ratio, and the arm containing capital R means this resistance is called standard arm, as we are going to set this resistance such that there is no deflection in the galvanometer, and the arm CD that contains the unknown resistance is called unknown R, right? So now we are going to find or derive this balance condition using Kirchhoff's law, this balance condition using Kirchhoff's law. To do this, we are going to apply Kirchhoff law in Wheatstone bridge in both the loops one by one. So suppose first we are taking the loop A, B, D, A in clockwise direction. I am taking the loop A, B, D, A in clockwise direction and applying Kirchhoff's second law or Kirchhoff's voltage law in loop A, B, D, A. Then I'll be getting, right, so for this we must have the currents. Let जो सेल हमने लगाया है वहाँ से करंट फ्लो कर रहा है I, and at point A this I splits into I1 and I2, right, I1 and I2. In this terminal from B, the current going through galvanometer, let it be Ig. In the condition of balance, this Ig value will be 0. Now the remaining current that moves from B towards C will be I1 minus Ig, and here this Ig meet at point D, then current moving from D to C will be I2 plus Ig, and at point C these both currents meet and gives the value capital I. Okay, so these are the currents. Now applying Kirchhoff's second law in the loop A, B, D, A, so we can see for the resistance P, the direction of this motion and current are same, so we are going to get the term I1 into P in positive. Then for this galvanometer, let the resistance of galvanometer is capital G, then this value again will be in positive because our direction of motion and this direction of currents are same, so we will be getting Ig into G in positive. But in case of the resistance capital R, the direction of current and direction of motion are opposite to each other, so we will be getting this term in negative, that is minus I2R. So the equation will be I1 P in positive plus Ig capital G again in positive minus I2R. Since there is no cell connected in the loop, so it will be equal to 0, means summation E term will be 0, right? This is the equation for the loop A B D A. Now for the next loop, that is B C D B, applying Kirchhoff's voltage law in the loop B C D B. Again we are going in clockwise direction, right? In clockwise direction. So what will be the answer? This for the resistance Q, the direction of current I1 minus Ig and our motions are in same direction, so it will be in positive, that is I1 minus Ig into Q. For the resistance capital S, the direction of current and direction of motion are opposite to each other, so it will be in negative, means minus ka I2 plus Ig into S, right? And for this terminal, means galvanometer, again the direction of current and direction of our motion are opposite to each other, like current is like this from B to D and we are going from D to B, so these are again in negative minus Ig G. There is no cell or battery connected in the loop, so right side will be 0. These are the two equations. Now in balanced condition, this is the condition for balance. In balanced condition, galvanometer will be showing no deflection. That means there is no current in this terminal, or we can say Ig is equal to 0. So in balance condition, there is no current flowing through the galvanometer, or we can say the value of Ig will be 0. Substituting these values in the above two equations, we get I1P minus I2R is equal to 0 and I1Q minus I2S is equal to 0, or this implies I1P is equal to I2R and I1Q is equal to I2S. Let these be equation number 1 and equation number 2. Now dividing equation 1 by 2, we will get I1P upon I1Q is equal to I2R upon I2S, and it implies P upon Q is equal to R upon S, which is the required condition for a balanced Wheatstone bridge that we have mentioned here. So this is the condition we derived from Kirchhoff's law under balance condition, and this is why we called it as the condition for the balanced Wheatstone bridge. Alright. So what is a Wheatstone bridge? Wheatstone bridge is an arrangement of 4 resistances that is used to find one unknown resistance accurately in terms of the remaining 3 resistance. If that unknown resistance is capital S, then we can write it as S is equal to Q upon P into R, and this condition is known as balanced condition because we considered that while writing this there is no deflection in galvanometer, or we can say that Wheatstone bridge is balanced. Now the another important point that we have to study is sensitivity of a Wheatstone bridge. So the question is, what is sensitivity? Mean क्या सिग्निफाई करता है सेंसिटिविटी? सो सेंसिटिविटी बेसिकली मीन्स कि जो भी आप व्हीटस्टोन ब्रिज यूज़ कर रहे हो वो कितना सेंसिटिव है टू द चेंजेस. लाइक अ व्हीटस्टोन ब्रिज तब सेंसिटिव ज़्यादा होगा इफ़ इट शोज़ लार्ज डिफ्लेक्शन इन द गैल्वेनोमीटर for a small change of resistance. Means वो स्मॉल टू स्मॉल चेंजेस को भी डिटेक्ट कर पाएगा, दैन इट इज़ कॉल्ड सेंसिटिव Wheatstone bridge. So to have a sensitive Wheatstone bridge, we have to remember certain conditions, like how we get a sensitive Wheatstone bridge. There are two factors on which this sensitivity depends. First, the magnitudes of resistances in four arms. So जो वैल्यू है रेजिस्टेंसेस की, इट affects the sensitivity of a Wheatstone bridge. So bridge will be most sensitive when all the four resistances are of same order. अगर Wheatstone bridge में हमने चारों resistances same order के use किए हैं, then in that case जो आपका Wheatstone bridge है, it will be most sensitive and it will detect minute changes in the resistance. So उसका जो गैल्वेनोमीटर होगा वो माइन्यूट चेंजेस के करस्पॉन्डिंग भी डिफ्लेक्शन शो करेगा. दैट इज़ अ गुड थिंग. तो आप बहुत एक्यूरेटली डिटेक्ट कर पाओगे कि वो बैलेंस्ड है या नहीं है. सो वी हैव टू कीप इन माइंड दीज रेजिस्टेंसेस शुड बी ऑफ सेम ऑर्डर to attain highly sensitive Wheatstone bridge. Right? Second factor on which this sensitivity depends is the relative positions of battery and galvanometer. It also depends on relative positions of battery and galvanometer. Right? These two factors are responsible for the sensitivity of a galvanometer, and a Wheatstone bridge is said to be sensitive if it shows large deflection in the galvanometer for a small change of resistance in the resistance arm. Right? Small minute changes के लिए भी resistance arm में अगर वो large deflection show करता है for the in the galvanometer, then it is called a sensitive Wheatstone bridge, and it depends on the following two factors. The next thing that we are going to study is advantages of using this method to find a resistance. Means why we are going to find or why we are choosing this method to find an unknown resistance. So what are the advantages for using a Wheatstone bridge method? So the very first advantage is that it is a null method. Now वो इससे एडवांटेज क्या हुआ हमें? इट इज़ अ नल मेथड. So basically what we are going to do in the process is we are working for getting a null point. Means हम Wheatstone bridge को ऐसा सेट करना चाहते हैं कि उसका जो गैल्वेनोमीटर है वो हमें डिफ्लेक्शन शो ना करे. दैट मीन्स वो नल पॉइंट अटेन कर ले. एंड दिस नल पॉइंट, ये जो नल पॉइंट वो अटेन करेगा, दिस नल पॉइंट डज नॉट डिपेंड ऑन either on internal resistance of the cell or on resistance of the galvanometer. Means ना तो ये सेल के internal resistance पे डिपेंड करता है और ना ही resistance of galvanometer पे डिपेंड करता है. So both these factors are not going to interfere in our observations during this method. So that's why we are using this process. So the very first advantage for using a Wheatstone bridge to find an unknown resistance is that it is a null method, and while finding the null point it remains unaffected by the internal resistance of the cell as well as the resistance of galvanometer. Both these factors will not affect the process. That's why we can find the null point or we can find the unknown resistance accurately. Now the second factor, second advantage is in the whole method we are not finding or not involving any kind of current or potential difference, due to which the resistance of ammeters and voltmeters will not be affecting the measurements. Means in the whole process हमने ना तो कोई current include किया है measurements में, किसी current की हमने help नहीं ली है, neither we are taking any potential difference, so that's why we are not in the need of ammeters and voltmeters in the circuit. And since there are no involvement of ammeters and voltmeters, so that's why their resistances are not going to affect our readings. Means the second advantage is, as there is no involvement of any current and potential difference, so due to this, resistance of ammeters and voltmeters do not affect the measurements, right? So these factors are not going to affect the measurements of resistances or our readings. The next factor or the advantage because of which we are going to use this method is the unknown resistance that we are going to measure by this method is going to be a very high degree of accuracy, and by increasing the ratio in the arms P and Q, ratio of resistances in the arms P and Q, we can increase its accuracy. Means how accurately our Wheatstone bridge is working depends on the ratio Q upon P. So by increasing this ratio, by increasing the ratio of these resistances, we can increase the degree of accuracy. If we increase the ratio, the degree of accuracy of finding the resistance will also increase, so we will be getting more accurate result by using this process. One more thing we have to note is that the Wheatstone bridge method is not suitable for measurement of very low और very high resistances. इस मेथड से हम बहुत लो और बहुत हाई रेजिस्टेंसेस को कैलकुलेट एक्यूरेटली नहीं कर सकते हैं, बट विद इन द मीडियम रेंज दिस मेथड is good and quite accurate for the use. So what is the condition? It's not that accurate or not suitable to find very low and very high resistances, right? So this was all about the Wheatstone bridge. In the next video we will be studying meter bridge, or we also called it as slide wire bridge, which is actually the practical application of Wheatstone bridge. Till then, you study hard and stay safe.